We will wait for the participant to join, doctor.
Okay. So once you tell me start, I'll start.
Sure, doctor.
Hmm.
So we have now 5 attendees. Still in counting. Now 6.
Can you change my background or
If you want, doctor, you can, but yep.
no, that's fine.
But your background is good, doctor. Like it's pure
Okay,
white. Yep.
perfect.
So, doctor, we are live now, and we started the recording. So you can start the presentation now, doctor. Thank you.
Okay, thank you, Mr. Patrick. So it's my pleasure to have you in this webinar, which will be about the exploring of future renewable energy. Actually, here the future could be about the applications, the regulations, or the technology. So I'll try to cover as much as possible within the time given. My name is Dr. Anas Al-Tarabshi, Associate Professor in Semiconductor Materials and Renewable Energy in the Electrical, Computer and Biomedical Engineering Department at Abu Dhabi University. Now, when we say the future of renewable energy, we mean the energy should be affordable, accessible, reliable, and sustainable. This is what we mean by the future of renewable energy. Now, before we start, I'd like you here to be engaged in this webinar by scanning this code. So please take a photo of this code, QR code, or you can copy this link. Okay, just to see your responses. Okay, so great. The energy forms could be solar, as you have mentioned, hydroelectric, geothermal, solar, wind, and biofuel or biogas. That's fine. Perfect. Okay. What about the question number 1? No, sorry here. Okay, so once you are done, okay. By the way, here those questions are very simple, and I want to check your background. If you can't solve them, that will be fine. Okay, good. Now the outline of this presentation will be like the following. Here we will be answering the following questions: what will be the most common renewable resources, and what are the energy forms, and then what are the drivers and the motivations for the energy transformation, and then what is the future of renewable energy technology, and then we will answer the question, what's the energy market of the future, and then we will conclude our webinar. Okay. Now, the most common renewable resources, as you know, here I will mention the most five resources, which are the solar energy, the wind energy, the hydropower energy, and the geothermal energy. Number five, the biomass energy. This is what you already showed in in your answers. Now, the hydroelectric plants here, the installed power for the hydroelectric plants about 1,295 gigawatts. The wind farms share about 563 gigawatts, while the solar or the PV generate about 486 gigawatts. So those are the main three types of the renewable resources that generate enough power. Now, why do we talk about the solar panels all the time? Because this is the most talked about source of sustainable energy. They are the most accessible sustainable energy technology for the property owners. Okay, good. Now here, this is the solar energy system. The radiation is converted to electricity, and this electricity is DC, as you know. This is why we need an inverter that converts that DC to AC such that we can utilize that power. We have somewhere a meter that counts how much power is generated and how much power is consumed. Generally speaking, how to find the power generated from the system, we multiply the rating of the PV modules by the total efficiency of the system. Okay. And this is right now for the wind energy. As you know here, the kinetic energy is converted, the kinetic energy is converted to mechanical in the shaft, and that mechanical is converted to electrical, right, using the generator. Now, how to find the total electrical power? We will multiply the power confined in the wind, which is half times the air density times the swept area times the air speed. This is how we find the electrical power. Now, number three, the hydropower energy. Here we convert the potential energy to kinetic energy, then to mechanical energy, then to electrical energy. And this is using this formula where Q is the flow rate of the fluid, normally this is water, times the rho, which is the density of the water, times the gravity here, acceleration, times the head height, which is the height difference between the intake and the turbine here. Number four, guys, the geothermal energy, by which here we convert the high heat confined in the earth here, and then this depends on the difference in the temperature between the inlet and the outlet temperature. Okay, this is how we find the power. Rho is the fluid density, CF is the specific heat capacity, Ti and T node are the input and output temperatures for the geothermal plant. Okay, now this is number five, which is the biomass energy. Now, as we know, the biomass power generation uses the heat from the combustion of organic waste derived from plants and animals as fuel. Now, the question here we may ask ourselves, does burning biomass fuel have a negative impact on the environment? Actually, the biomass power generation is carbon neutral. Now, what we mean by that, the biomass fuel emits carbon dioxide when burned, but this CO2 is absorbed by the plants for photosynthesis process and the growth. Now, so the amount of the carbon emitted by plants is considered the same as the amount of carbon absorbed. Okay, good. Now, this is the energy forms. As you answered, we have chemical energy. Okay, we have potential energy, radiation, electrical, mechanical, thermal, and kinetic. So here, this is, we convert the energy from a form to a form. And here we have this table that shows different examples where the input energy is shown, the output energy is shown, and the efficiency of the corresponding systems is shown as well, which is the ratio between the output power and the input power. Okay, now what are the drivers for the energy transformation? Now, as we know, the climate change has become a major concern of this century. The urgent response to that concern is an energy transformation, okay, that reduces the carbon emissions that cause the climate change. Now, what's our goal? Our goal here is to limit the increase of global temperature to below 2 degrees Celsius. Now, to realize this, the climate target, which is a transformation of the global energy, is essential. Such as transformation is possible with the replacement of what? The conventional fossil fuel generation with low carbon technologies. Now, decarbonizing the energy sector and reducing the carbon emissions are the key objectives of the energy transformation. However, the reduction of the carbon emissions is not the only reason why the world should embrace the energy, okay? Now, there are other factors, of course. Now, as we see here in this figure, those are the main pressing needs. So, of course, investing in the renewable will create many jobs. It will make the energy accessible, and it will improve the energy security. Of course, the air quality will be improved. The carbon emissions will be reduced. And of course, the energy costs are decreasing, of course. So those are the main drivers for the energy transformation. Now, the first one is the reduction in the costs, as we mentioned here, okay, the falling energy costs. Now, in most parts of the world, renewables have become the lowest cost source of a new power generation. The costs continue to fall for the solar and the wind technologies. So as we see here, the cost for a kilowatt hour for the concentrated solar power decreases from, if you compare from 2018 to 2030, it decreased about, or it should decrease about 35%. For the solar PV, it will decrease about 58%. For the wind offshore, 55%, and for the wind onshore, about 25%. Now, however, between 2012 and 2018, the levelized cost of energy of solar PV fell about 77%, the concentrated solar power by 46%, the onshore wind by 35%, and the offshore wind by 20%. So here the idea, the reduction in the costs is a main driver for the future of the renewable energy. Now, what does the transformation here entail? Now, the total share of the renewable energy would need to rise from around 14% of the total primary energy supply. If we compare to, for example, to 2017, to around 65% in 2050. Okay, good. Now, under the transforming energy scenario, the renewable share increases to how much? To 65%. Perfect. Now, the renewable energy here mix change with the share of renewables from bioenergy decreasing from 2/3 to 1/3, and with a much higher share of the solar and wind based in the transforming energy scenario in 2050. Now, again here, the total installed capacity would be needed for the solar to reach the goals, to get 80% share. We have to install extra 8,519 gigawatt, while for the wind, we should install about 6,000 gigawatt. For the hydropower, we should install extra 2,147 gigawatt. Okay, so this is the future for the renewable. We see the investment in the or the installed power in different renewable resources here. This is for the PV, and this is for the wind, and this is for the hydropower. Okay. The second driver here is the smart charging of the electric vehicles, or let us say the integration of electric vehicles. Now, as we know, the electric vehicles present a viable opportunity to introduce much higher shares of renewables into the overall power generation mix. Such developments offer a decarbonized transport while also cutting air and noise pollution. Okay, so reducing the fuel import dependence and adopting new approaches to urban mobility. Okay, now scaling up the electric vehicle development also represents an opportunity for power system development with the potential to add much needed flexibility in the electricity systems and to support the integration of high share of renewables. Now, some regions, especially in the European Union, are promoting right now electromobility, and some countries have ambitious objectives to phase out the internal combustion engine sales by 2030, 2040. Okay. Furthermore, the electric vehicle development must go in hand with more rapid penetration of renewables in the electricity mix. Now, one motivation actually, if you look at the practical cases, now we find almost our cars, including the electric vehicles, by the way, typically spend around 95% of their lifetime were parked, right? So the question here, why not utilize that time to charge those cars? Now, if you look how many cars or how many electric vehicles are made here in 2010, we had about or less than 0.5 million. In 2018, 2019, we had 7.9 million. We expect in 2030 about 379 million of cars. 2040, 744 millions. 2050, about 1,109 million of electric vehicles. So this is another part of the future of renewable energy. The third parameter or driver here is the decarbonization of the world's energy system. Now we know that scaling up the electricity from renewable is crucial for the decarbonization of the world's energy system. Now the electrification with renewable is a major solution, and the contribution of renewable electricity, as we know, will be the single largest driver for change in the global energy transformation. Okay. So as we see here, this is the share of the renewable in the transport. Okay, it will increase from 3% to 56%. In the industry, it increases from 13% to 62%. While in the buildings, it increases from 35% to about 81% by 2050. This is if we, of course, if I go back, if we adopt those drivers. Okay, good. Now, the fourth driver is the IoT, or the Internet of Things, as a driver for the power system transformation. Now, we know that the digitalization is a key amplifier of the power sector transformation. Our digital world is becoming even more interconnected, as we know. The growing importance of digitalization in the power sector is partially a consequence of increasing the decentralization. Now, what we mean by the decentralization, that it means we increase the deployment of power generators at the distribution side, not at the generation side. Number two, the electrification, which means the use of electric vehicles. Now, as we know, the IoT is one of the digital technologies that can support the energy transition. The IoT transforms physical objects into smart devices here. What I mean here by smart devices, it means the devices that collect, communicate, monitor, and interpret information, inform their surroundings in real time. By the way, by 2025, 75 billion devices worldwide are expected to be internet connected. Okay, good. Now, what about the energy investment? Now, government plans here in place today call for investing at least 95 trillion US dollar in the energy system over the coming 3 decades. Cumulative energy sector investment over the period of to 2030 is shown below. So as we see here, by 2030, we will be investing about 60 trillion USD dollar, and this is the share of each renewable resource. Good. Now, what is the future of renewable energy technology? The first one is the inclusion or the integration of nanotechnology. So the nanotechnology here is advancing so rapidly these days. It seems there is a new nanotech breakthrough being reported on a daily basis. Now, the top researchers from around the world are using the nanotechnology in different fields, and the renewable energy is part of that or of those fields. Okay. The second future of renewable energy technology is the solar farm in space. Just I want to share with you this video. I don't know whether you can hear the voice or not. Can you write it, guys, in the chat whether you hear it?
No, doctor. We
No.
cannot hear the sound.
Okay, that would be fine. So I will be right now. I can explain it in simple words. Now, one way to harness the solar power in the space would be able to launch tens of thousands of solar satellites. This is what I mean here. Okay, that would link up to form an enormous cone-shaped structure that orbits around about 22,000 miles above the Earth. Now, as we know, the satellites would be covered with the photovoltaic panels needed to convert the sunlight into electricity. Now, one major point here, as we know, the higher the elevation, the more the solar radiation, and the temperature will be even lower, which will be perfect situation for the solar cells. So in this case here, all the time, what we generate from the cells will be emitted using special devices, which would be here converted into microwaves and beamed wirelessly to ground-based receivers, giant wires nets measuring up to 4 miles across. So this could be installed over lakes or across deserts or farmland. Now, one good point here that we can have, which is written here, such solar facility would generate a steady flow of 2,000 gigawatts of the power, while the largest terrestrial solar farm right now is only about 1.8 gigawatt. So this is one of the promising technologies and the number 3, the floating solar farms, which you can call it photovoltaics. Now, in this case here, we prevent the water from evaporation. Number 2, the operating temperatures of the PV modules will be kept low, which will be ideal for the operation of the PV modules. And then the solar paint, which will be huge, or it will be totally different than the existing solar cells. Here, the cells are made by paint. So the idea of using the paint-like substance to generate the electricity has been discussed within the scientific community for many years. Now, only recently have the potential for real-world applications. Okay, so there are 3 separate innovations that are classified as solar paints. Here we explore what they are, okay, and what they might mean for the future of the solar energy. Now, to the right-hand side, if you see those colors or those liquids, those called are quantum dot solar cells. Now, the quantum dots here, also known as photovoltaic paint, they are nanoscale semiconductors that can capture light and turn it into electric current. Okay, now we can call it colloidal quantum dot photovoltaics, which are not only cheaper to manufacture, but also significantly more efficient than the traditional solar cells. Actually, there are 2 advantages for those quantum dots. First, they are much cheaper. Number 2, and simply here, by changing the size of the quantum dot, we can change the light absorption spectrum. That means we can utilize more the spectrum. Now, these dots could end up with 11% more efficient than the traditional solar cells. Now, in the future, we would have the ability to paint these quantum dots on our roofs, surfaces, in order to generate the electricity. Okay, now here there are three ways in which the solar paint could be used in the future. We can add solar paint to existing solar setups. So solar paint may work as a great way to enhance the existing solar setups. People with solar panels or solar could create an additional energy source by painting their roofs and walls with the solar paint. Number two, the solar painted vehicles. Solar paint could be a great way to add solar generating capacity to the vehicles. Number three, the standalone power generating solar setups with increased efficiency levels and cheaper production costs. High quality solar paint could one day start a primary source of power for our homes and businesses. And here, this is the PV windows. So as you see here, it's very transparent, but actually this transparent glass is a semiconductor material that converts the solar radiation into power. So we can use our the solar cells in the future for our windows. Okay, number 6 of the future technologies of the renewable energies is called the super efficient solar antennas. So we call it antennas here. So developing microscopic antennas, we call it antennas here, capture the sunlight in both the visible and the near infrared spectrum. This means here more efficiency compared to the existing cells. Also, we can utilize the energy from the sound. So just imagine while you are using your phone talking, during your calls, the power can be generated and it can be utilized. And also, we can utilize the noise and the sound from the vehicles in the tunnels, in the streets, wherever. What about the wind technology? So the next generation of the wind technology will focus on the development of the prototype and the components. This is for the power generation. Now, then we go to the storage of the energy. Now, storing energy with nanosponges. Now, creating carbon nano supercapacitors, we call them nanosponges here, which are capable of storing static electric energy in their sponge-like pores. So the nanosponge here can deliver energy faster and more efficiently than the chemical-based batteries, okay, and but at a far higher capacity. Now, regarding the energy market, now we know the smart electricity grids are a priority. Smart grids fulfill the promise of distributed energy resources. Tomorrow's energy grid will be defined by intelligent electronic devices, phasor measurement units, smart meters that communicate in two ways between the customer and the utility, and other technologies. Now, this technology will allow finer control over the network and a two-way exchange of the data among the utilities, generating sites, okay, and customers. Now, tomorrow's grid will be able to dynamically optimize the flow of energy to account for the supply and demand. Okay, now the proliferation of the smart devices also means utilities can pinpoint outage quickly and respond precisely whenever the problem arises. Now, most importantly, smart grids recognize that electrical power can be generated almost anywhere and from a wider variety of sources than ever. They turn utilities into energy markets with participants able to purchase power from almost any place. Okay. Now we reach the conclusion here. Actually, the future of renewable energy is brighter than the sun itself. The world in the middle of a huge transition that would have to make to renewable energy. So we have a transition away from the fossil fuel very quickly. We have to. Number 3 here, we should be ready for another industrial revolution in the field of renewable technologies. By this, I thank all of you for your patience and for your listening.
Hello everyone. If you have question, you can post your question in chat or in the Q&A tab, or you can raise your hand
So, Mr.
and I will
Patrick, are
allow
you
you to
there?
talk. Yes, doctor.
Um, so, if you have any questions, it is my pleasure to take your questions. Um, Mr. Patrick, are you there?
Yes, doctor, I'm here. Hello, doctor.
So let me take the questions from the chat. Any questions, guys? Okay, so if there are no questions, I would like to thank you one more time. Okay.
Thank you, doctor. Thank you, everyone.